Hello and welcome to another video. In this video we're going to be working on boats to save people. And in this one you're given an array of people where people I is the weight of the ith person and an infinite number of boats, where each boat can carry maximum weight of the limit. And each boat can also carry only 2 people, provided the sum of the weight is at most limit. So return the minimum number of boats you can have. So in this first one you have 2 people, you can just put them both on one boat because they're going to have a weight of 3. In the second one, you can do something like this is 1, this is 2, and this is 3, so 3 boats. And in the third one, you can't put 2 people on a boat because 2 of them together are bigger than the limit. So the main thing to figure out here is like how you're going to want to put people. And the main thing to realize is, like, let's say our limit's like 25. You don't want to, like, if I say I'm going to take this guy, and like if my goal is like I'm just gonna take the biggest guy and the next biggest guy I can put on, there's a couple problems with that. First of all, you're gonna be deleting from the middle, right? So then like you're gonna have a bunch of like empty spaces, and then you're gonna it's hard to like find where to get the next guy. Second of all, this doesn't actually help you. So if I actually take this guy and this guy, or I take this guy and the smallest guy, it will be the same. Because if I take this guy and this guy, right? Because if my goal is just like, let me just maximize the weight, I'm always going to take the biggest guy available, and let me take like the next biggest guy who could fit, and that's going to give me like the best. Well, if I take that, then for all of these, I know for sure that all of these will be available. Like I know for sure that any one of these will be a pair that works, because all of these are smaller than this, and all of these are smaller than this. So if you take this, you can do that, but if you take this, basically you can kind of prove that if you were to take these two, and like let's say these two were like the next two were too big, like these two couldn't fit in a pair, that means this number would have to be bigger than this number here. It would have to be over here somewhere. So that's why you can always take like the smallest guy possible, because and also, by the way, notice that if the next number, right, let's say I take these two and like these two didn't work, that means this number would have to be over here, and then that number would also be too big to take with this, right? Like if the next smallest available guy, if the smallest available guy wasn't, like, if these didn't work, this number would have to be over here somewhere, and it couldn't be a pair with this guy. So basically, you can kind of like, I think it's reasonably simple to tell, but a lot of people ask like, well, can you give me like a proof? So I don't know if I can give like a proof, but hopefully that makes a little bit of sense, where like you don't need to take the 2 people that get closest to the limit. You just need to take the biggest guy and the smallest guy if possible, because if that's not possible, that means that the smallest guy is actually going to be like too big for like let's say the smallest guy was too big, right? If the smallest guy was too big, let's say the smallest guy was like or let's change the limit. So let's change the limit to 16. Now the smallest guy is too big to take with this, and then it wouldn't work. But it doesn't help you at all to just like, and you can try this out. You can try this out with like a few different things. Taking the biggest guy and like the biggest thing that fills up the boat, it doesn't help you at all. And it's actually going to be much easier in the code to always just take the biggest guy and the smallest guy together. So once you know that, once you realize that from, like I said, doing a couple of examples, then the problem becomes really easy. But that's kind of like the hard part of the problem, realizing that the greedy optimal solution is just take the biggest guy and the smallest guy. And yeah, hopefully you can figure out that, like, hopefully you can figure out why that is for my other thing, where like if you couldn't do that, or, you know, if this was possible, then these are going to be possible with all of these, so it doesn't really matter. Like it's going to give you the exact same result. So basically the idea now is like, let's say our limit's like 16 or something. Now you basically have 2 choices. You either take the biggest guy and the smallest guy, or if the biggest guy and the smallest guy is too big, you just take the biggest guy, and then you just count up your number of boats. So now, like in the beginning, I can't take both of them because it's too big, so I'll just take the biggest guy. Then I'll move this in. Now I can take both of them. So if I take both of them, so this is boat number 2, then I'll move both of them in. I can take both of them again, so this is boat number 3. I can't take both of these, so I'll just take this big guy. So that's 4 boats. Now I can take both of these, so you move them in. And now I can take both of these as well, and then they just like cross, and then you're done. So essentially, you just have 2 pointers, like a left pointer and a right pointer, and you keep taking people up until there's nothing else to take. And you basically have a choice of either take biggest or take biggest and smallest, and you either move 1 pointer in or both. So hopefully that makes sense. And I know a lot of people get to the solution of like, well, I could just take like the as big of a number as I can to get the limit. And like I said, first of all, it doesn't matter. Second of all, you're going to be deleting a bunch of stuff from the middle, and then you can't really use pointers to do that. So it would be a lot trickier. But if you could code that up in O of n, that would give you the exact same solution. Because yeah, like if you were to take this and this, then all of these would just be available for the next few numbers. So it would be the exact same thing. Okay, so let's code that in Java. So we're gonna sort the people, and then we're gonna have 2 pointers. So we'll have left equals 0, right equals let's see, people length -1. And then we do have to figure out like what we do, like as we move these pointers together, like what would happen if they're on the same thing. So I guess we can just say if they're on the same thing at the end, we can just break our loop, because that's only 1 person, and we don't want to like add them together. So I guess we could do that. So we could say like while left is less than right. So basically we have 2 choices, right? So if left and right is big enough to fit into 1 boat, then we'll move them both in. Otherwise, we will only take the right guy, and then we'll have a boats. Okay, so we can say like if people left plus people right is less than or equal to limit, we will move them both in because we can fit them both. Otherwise, so really all we need technically, I guess. So you're always going to use 1 boat, and you're always going to move the right guy down. So this is the only one that changes based on this loop, right? So we can just do everything else outside of this loop. So you can say this means you take 2 people, and everything else will just be this. In fact, you can probably, your result can just be based on like how far the right pointer is from the end of the thing, but whatever, this is easier. So yeah, so regardless, we're always going to take the big guy, and we're always going to take a boat. Now we just basically have to check, like, so in this case, we just have to check, like, is left equal to right? And if left equal to right, we need to return one more boat, because there's like 1 more person left. So we can just say it like return left equals right, boats +1, or boats. So this works. You could code this in other ways, but this works. So. But yeah, the main thing for this one is literally just recognizing that the best thing is to take the big and the small guy, and then from there it's like an easy problem pretty much. But yeah. And you could get to that solution just by trying a bunch of things out. You could alternatively do some kind of DP thing, but I don't think it'll pass, because then for every single, like I said, you'd have to have things deleted from the middle, and then it would just get kind of tricky. So hopefully that makes sense. Pretty easy one. So here we have a n log n solution, and space is O1. Yeah, so not much to this one. I think the first few problems of the month are all pretty easy, so we'll see if they get some harder stuff. And I'll be doing like the contest problems on the weekend, so those are definitely going to be harder. But yeah, thanks for watching, and I'll see you in the next one.